Hello, my name is Lumila, and I will be presenting today the results of a teamwork collaboration. The aim of this project is to evaluate the impact that climate diversity has in shaping the cranial variation in humans coming from temperate and cold climates. For doing this, we compiled a large dataset of more than 3,000 individuals coming from North America and South America. Additionally, we collected data on environmental variables and genetic datasets in order to match those samples to test our hypothesis. Samples were grouped following Köppen climate classification. Samples from cold climates are depicted in violet, while the temperate ones are depicted in pink. On the left, you can see the measurements that we used in our analysis, some of them describing the whole skull, while some of them describe more local anatomical structures. We conducted several statistical analyses, so here I will be showing only some of them. These are the results of a partial least square analysis among samples from North America, combining climate and morphometric variables. As you can see in the left, samples from cold climates show an increment in all facial dimensions except for the facial protrusion. On the right, you can see that samples from cold climates present lower and longer cranial bolts. We found similar trends among samples from South America. Samples from cold climates, depicted in violet, show an increment in all facial dimensions, including facial protrusion. For the cranial bolt, we can also see that samples from cold climates show longer and lower cranial bolts. The distribution maps illustrate these trends across the continents. You can see that in the left, samples from the South and South America show the larger facial skeletons. In the right, the cranial bolt show much weaker trends. This table summarizes all the statistical analysis that we conducted. Overall, you can see that simple mantle and spatial regressions show high and significant correlations between climate and morphometric variables. To conclude, some final remarks. The association between the facial skeleton form and climate is high and significant. In South America, we found that populations from the cold climates present the larger facial skeletons. Also, the association between cranial bolt and climate is low to moderate. Populations from North America, from cold climates, present the larger cranial bolts. Overall, populations from cold climates present an increment in nasal and facial height, orbital height, and width. They also present larger and lower cranial bolts. We think that the similarities could be explained as a result of parallel adaptations occurring through canalization due to being exposed to similar environments. The differences between North American and South American samples in cold climates could be explained also by cultural adaptations, such as, for example, the use of fire and clothing. We think that these cultural developments help in coping with such harsh environmental conditions. Thanks for listening to my video, and don't hesitate to contact me in case you have further questions or do want to discuss my research.